The output voltage from an op-amp depends upon three important factors. The first one is the voltage gain of the op-amp. So first thing is voltage gain. Second thing is the polarity relationship between the inputs V1 and V2. And third is our supply voltage VCC we supplied. സോ ഒരു ഒപ്പാമ്പിൻ്റെ ഔട്ട്പുട്ട് വോൾട്ടേജ് ഈ മൂന്ന് പാരാമീറ്റേഴ്സിനെയും മൂന്ന് ഫാക്ടേഴ്സിനെയും ഡിപ്പെൻഡ് ചെയ്യും. സോ വാട്ട് ഈസ് ദി വോൾട്ടേജ് ഗെയിൻ ഓഫ് ദി ഒപ്പാമ്പ്? ദർ ആർ ടു ടൈപ്സ് ഓഫ് വോൾട്ടേജ് ഗെയിൻ ദാറ്റ് ഐ ക്യാൻ ഡിഫൈൻ. വൺ ഈസ് AOL, അതായത് ഗെയിൻ വിത്ത് ഓപ്പൺ ലൂപ്പ് വോൾട്ടേജ് ഗെയിൻ, ആൻഡ് അനദർ വൺ ഈസ് ക്ലോസ്ഡ് ലൂപ്പ് വോൾട്ടേജ് ഗെയിൻ. ഫസ്റ്റ് ഓഫ് ഓൾ വി ക്യാൻ ഡിസ്കസ് അബൌട്ട് ക്ലോസ്ഡ് ലൂപ്പ് വോൾട്ടേജ് ഗെയിൻ. Closed loop voltage gain. So let us consider a amplifier circuit. Now if you consider this amplifier circuit, here in the non-inverting input I have applied the input. The input is applied to the non-inverting input V2, and the positive terminal, that is the inverting terminal, is grounded. Actually this is not positive terminal, ഇത് ഇൻവേർട്ടിംഗ് ടെർമിനൽ ആണ്. നമ്മുടെ പോസിറ്റീവ് സിം എന്നുള്ള ഒരു സിമ്പൽ കൊണ്ട് അതിനെ റെപ്രസെൻ്റ് ചെയ്യാണ്, പൊളാരിറ്റി ഇല്ല അതിന്, ജസ്റ്റ് അത് റെപ്രസെൻ്റ് ചെയ്യാൻ വേണ്ടി യൂസ് ചെയ്യാണ് പ്ലസ് സൈൻ. ഓക്കെ, then from the output now we have a feedback circuit, and RF is connected from the output to the input. Now because of the presence of this feedback circuit, we call this circuit as the gain of the circuit will be closed loop gain. Closed loop gain, ACL. Always ACL will be very much less than AOL, that is open loop gain. So in case of open loop gain, this feedback resistance will not be connected. This circuit, in the circuit this resistance ഇവിടെ ഉണ്ടാവില്ല. Okay, so that's about the voltage gain of an op-amp. Now second thing about the output voltage depends is the polarity relationship between the input. So what is the polarity relationship? Suppose this is represented as V1 and this is V2, then the output voltage will be equal to gain times V1 minus V2, because an operational amplifier is a differential amplifier. This is we have already discussed. So output A times V1 minus V2 ആയിരിക്കും. Okay, now suppose V1 is equal to some 2 voltage and V2 is equal to some 1 volt. Then what will be output voltage? Output voltage will be gain times V1 2 minus 1. So this will be equal to some positive value. But suppose V1 is equal to minus 2 voltage and V2 is equal to minus 1 voltage, then gain V will be equal to, this will be equal to output voltage will be equal to gain times V2 is now minus 1 volt minus 2 volt. So V1 minus V2, V1 minus V2. So V1 minus V2 will be equal to gain times V1 is minus 2 volt and V2 is equal to minus 1 volt. So this will be equal to minus 2 volt plus 1 volt, that is minus. So the result will be negative. Then output voltage will be negative. Now let us take another possibility. V1 is equal to 2 volt and V2 is equal to minus 1 volt. Then output voltage will be equal to A gain times 2 volt minus 1 volt. So this will be gain times 3 volt, and so output voltage will be positive. So according to the polarity of between V1 and V2, according to the value of V1 and V2, the output voltage can be positive or negative, and this we call as the polarity relationship between the input. Okay, so the output, remember one thing, the output voltage V out is equal to gain times V1 minus V2. This equation you have to remember. The next thing that the output voltage depends upon is the supply voltage. The supply voltage. Generally, the supply voltage of an op-amp are normally equal in magnitude and opposites in sign. That means if the plus voltage is plus 15 volt, then minus V will be equal to minus 15 volt. So I am talking about the plus VCC or plus voltage and minus voltage that we apply. Okay. Now suppose this plus voltage is 13 volt, then here we will give minus 13 volt and so on. Okay. Then the plus V saturation, the V saturation will be equal to plus V supply minus 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 2V and minus V saturation will be equal to minus V supply plus 2 voltage. So in this case, in the first case, since I am applying plus 15 and minus 15, the plus V saturation will be 15 minus 2 and that will be equal to 13 volt, and here you will have 15 minus 15 plus 2 volt and that will be equal to minus 13 volt. So that will be the V saturation. Very important application of op-amp is inverting amplifier. So first of all, the circuit of an inverting amplifier. First we have to connect ground to the non-inverting input. So I will connect ground here, ground to the non-inverting input. Now let us discuss about one of the very important application of operational amplifier, which is inverting amplifier. So first of all, the circuit of an inverting amplifier. We have to connect the non-inverting terminal to the ground. So the non-inverting terminal is grounded. Now an input resistance is connected to the inverting terminal. So this is my input resistance Ri, and here I am applying a voltage source, an AC source, and this terminal is grounded. Now from the output I am taking a feedback resistance to the input, and so this is, since feedback resistance, I will call it as Rf, and this is the V out or output terminal. So this is my circuit, and now let us take this end terminal as A. I am calling this this end as A, and the in non-inverting is called as B. Okay, so here I have named A and here we have B. Okay, now let us analyze the condition now. The op-amp, we know that an operational amplifier has high input impedance. So the input impedance is high. Impedance is very high for an operational amplifier. Now since there is infinite input impedance, there is zero current through the input impedance. Since the input impedance is high, there will be zero current to the inverting terminal or through the input impedance. And if current is zero, that means there is no voltage drop between the inverting terminal and non-inverting terminal. Hello. ആ ഞാൻ കുടിച്ചു കുറച്ച് കുടിച്ചിട്ടുണ്ട്. ഉം. ആ ഉം, ഉം, ഉം. ആ കുറച്ച് കഴിഞ്ഞിട്ട് വരാം കേട്ടോ. ഉം. About the inverting amplifier, which is one of the very important application of operational amplifier. First of all, the circuit. We have to connect the non-inverting terminal to the ground. Non-inverting terminal is connected to the ground. Now, an input resistance is applied at the inverting input, and that input resistance is Ri. And now you have to apply a voltage source here. I'm connecting an AC voltage source, and this terminal is grounded. From the output, let us apply a feedback to the input. So this is our feedback resistance from output to input, and we can call it as Rf. So this is the output. Okay, now let us analyze the situation. We know that an operational amplifier has infinite input impedance. So the input impedance of an operational amplifier is infinite. Now since input impedance is infinite, there is zero current. There is zero current through the input impedance. Zero current through input impedance. And if there is zero current through input impedance, that means there is no voltage drop between V1 and V2, or the inverting terminal and non-inverting terminal. This the inverting terminal and non-inverting terminal. That means zero. So ഞാൻ പറഞ്ഞത്, there is zero current through input impedance. That means this inverting terminaliന്റെയും non-inverting terminaliന്റെയും ഇടക്ക് there is no voltage drop because zero current ആണ്. Now if there is no voltage drop, then suppose this I am naming as the inverting terminal as A and the non-inverting terminal is B, then voltage at A will be equal to voltage at B. Why? Because there is no voltage drop between these two terminals. അതായത് ഈ പോസിറ്റീവ് ടെർമിനലിന്റെയും നെഗറ്റീവ് ടെർമിനലിന്റെയും ഇടയ്ക്ക് വോൾട്ടേജ് ഡ്രോപ്പ് ഇല്ല. Why there is no voltage drop? Because there is zero current through this input impedance. Why there is zero current? Because the input impedance of an op-amp is infinite. Now, if VA is equal to VB, now let us see what is VB. VB, since this terminal is grounded, B is grounded, we know that VB will be equal to 0 volt. Now, if VA is equal to VB, then VA will be equal to 0 volt. Now, if you consider this terminal, that means this point A, this point A is physically it is not grounded, but see this is at zero potential. VA zero voltage ആണ്, but physically അത് ground ചെയ്തിട്ടില്ല. Therefore, we can call it as virtual ground. Virtual ground. ഒപ്പാമ്പിന്റെ തിയറിയിൽ നമ്മൾ ഡിസ്കസ് ചെയ്യുമ്പോൾ വൺ ഓഫ് ദി വെരി ഇമ്പോർട്ടൻറ്റ് കൺസെപ്റ്റ് ആണ് വിർച്വൽ ഗ്രൗണ്ട്. സോ ഫിസിക്കലി ഗ്രൗണ്ട് ചെയ്യാത്ത ദിസ് പോയിന്റ് എയിൽ ഒരു ഗ്രൗണ്ട് ഉള്ളതുപോലെ വിർച്വലി ഒരു ഗ്രൗണ്ട് ഉള്ളതുപോലെ വരും, അഥവാ പൊട്ടൻഷ്യൽ സീറോ വോൾട്ടേജ് ആവും. ദിസ് ഈസ് വൺ ഓഫ് ദി വെരി ഇമ്പോർട്ടൻറ്റ് കൺസെപ്റ്റ്. സോ അവർ പോയിന്റ് ഈസ് വി എ ഈസ് നൗ zero voltage, or here we have virtual ground is now we have virtual ground, and here we have input voltage V in, and the current through Ri we can call it as I in, input current I in, and the current to the inverting input I am calling as I1. So what is I1? I1 is the current to the inverting input, and this I1 is 0 because of the infinite input impedance. Okay, and if I1 is 0, the current through the Ri, I in, I can show the direction like this will flow through the Rf, that means If. So I in will be equal to IF because I1 is 0. Actually, I in is equal to IF plus I1. But this term is 0. So I in is equal to IF. Okay. So this is an important equation that we will use after some time. Okay. Now what is I in? I in is equal to voltage across Ri by Ri, because V is equal to IR is our Ohm's law. So I will be equal to V by R. So I in will be equal to voltage across Ri. ഈ Riയിലുള്ള voltage divided by Ri. Now what is voltage across Ri? Voltage across Ri is equal to current നമുക്ക് ഈ directionലാണ് flow ചെയ്യുന്നത്. Current direction ഇവിടെ കാണിച്ചിട്ടുണ്ട്. So voltage across Ri will be equal to V in minus VA. That is voltage at this position ആണ് VA. ഈ എ എന്നുള്ള പൊസിഷനിലുള്ള VA by RI. Now what is VA? Ground, virtual ground ആയതുകൊണ്ട് VA 0 ആണ്. So V in by RI. This is I in. Okay. Now let us consider IF. What is IF? IF is the voltage across RF by RF. Now what is voltage across RF? Voltage across RF is equal to, now since current is flowing along this direction, current ഈ directionലാണ് flow ചെയ്യുന്നത്, so voltage VA minus V out വരും, voltage across RF. So this will be equal to VA minus V out by RF. Now VA is equal to 0. So we have IF is equal to minus V0 by RF. And we have the equation I in is equal to IF. So this term I in, that is V in by Ri, is equal to, so if I apply here, we have V in by Ri is equal to V out minus V out by RF. Now what is gain? The gain is output voltage by input voltage. So V output by V input is equal to minus RF by Ri, and this is the closed loop gain because now we have the feedback resistance here. So the closed loop gain of the op amp is equal to V out by V in, and that is equal to minus RF by Ri. Now there are certain things we have to point out. The first thing is we have a negative sign in the output. So what does this represent? The negative sign indicates that the output is inverted. The output is inversion of the input. The output is inverted. Second thing, the output voltage or the gain of the op amp ACL is independent of the open loop voltage gain, because the output voltage the gain of the op amp depends, or the closed loop gain depends only on RF and RI. നമ്മൾ externally connect ചെയ്യുന്ന feedback റെസിസ്റ്റൻസിനെയും input റെസിസ്റ്റൻസിനെയാണ് gain, closed loop gain depend ചെയ്യുന്നത്, and it does not depend upon the open loop gain. Okay, now the third point is so suppose RF is equal to Ri, then closed loop gain ACL will be equal to -1. So you will have unity gain with a 180 degree phase difference. Okay.